Okay, we just finished our study of the law of sines, and now I'd like to look at the law of cosines. The law of sines cannot always be used to solve all oblique triangles. When you are given two sides and the included angle, let me just kind of draw a quick picture of that. If you have a triangle, that was supposed to be a straight line. If you have a triangle and you're given, let's put some letters on it, A, B, C, and therefore this would be little a, this would be little c, and this would be little b. If you're given little b, little c, and capital A, that would not allow you to use the law of sines, because watch this box here. So you had A, B, C, and A, B, C here. And if you're given B, C, and big A, nowhere in this pairing of group of four do you have three. Look at right here, you have only two pieces of information in the B's and C's. And even in the A's and C's, you only have two pieces of information. You just can't use the law of sines. So this is a case 3 problem where you're given two sides and the included angle. So this angle is included between these two sides. The other situation is where you're given all three sides of a triangle. So when you're given all three sides of the triangle, it's called case 4. And both of these we have to use the law of cosines for. This is not, actually I don't know what I meant when I said let's prove this. This is a calculus problem to prove, so we're not going to do that. So let's just take a look at what the law of cosines looks like. It kind of looks like the Pythagorean theorem almost. Look at this, c squared equals a squared plus b squared. But there's minus 2ab times the cosine of angle c. There's three versions of the law of cosine. The example I just threw out at you just now, we were supposedly given side B and side C and angle A. If that were the case, I would be using this version of the law of cosines because I was given side B and side C and angle A. And that would allow me to solve for side A. If I was given A and C and then angle B, I'd use this version. Let's go look at the first problem. So in this problem, actually, so look, I've given you a problem where we're given side B, side C, and angle A. So let's write this in. B is 87.3, C is 34.0, and angle A is 130 degrees. Okay, so with that, the only thing I can do, I can't use the law of sines, is I can turn to this statement. A squared equals b squared plus c squared, which by the way should be on your note card, times the cosine of angle A. And then in order to find how the size of side A, you'd have to take the square root of both sides. So to do this calculation, I've got to take the square root of b squared plus c squared minus 2 times b times c times the cosine of angle A. Okay, so to type this, I highly recommend you just type it as you see it here. You just type it all in one fell swoop. So I would suggest second square root. Now my calculator may look different than yours. It may not have a parenthesis here, but it may have a radical bar above and it will extend. So I'm going to go 87.3 squared plus 34 squared. Notice how I don't bother with parentheses because I put these positive numbers in for B and C. So when I square them, I get a positive result. Then this is a minus sign, minus 2 times 87.3 times 34 times the cosine of 130. I don't need all those parentheses. Whoops, I missed the word cosine somehow. So the cosine of 130, and then I'll close my parentheses. Now I better close them again because that first set closed for the cosine of 130 right there. And then this one is to go with the beginning one right here. And when I hit enter, I found out that side A is 112.2. So side A is 112.2. Now, be careful. In a case 3 problem, you must go for, I'm going to put here case 3, check out your notes. You must go for the smallest angle next. Using law of sines. You must. And I'll try to show you why as we get ready to do the problem that follows. It doesn't particularly matter in this particular problem, but normally you must always go for the smallest angle. So which of these two is the smallest angle? Well, you go over here to decide. The angle that's the smallest is the one that's opposite the smallest side. So this is guaranteed to be the smallest angle. So you would use law of sines and solve for angle C next by going side, I'm going to do this in black. So you'd go side C divided by the sine of angle C equals side A divided by the sine of angle A. And then you take this product right here and divide it by the 112.5. Let's go ahead and do it. So we'll take 34 times the sine of 130, close the parentheses, divide by the 112.2. And then remember, that's a ratio for the sine of an angle. That doesn't look like an angle, does it? So go second sine, second answer, and we find out that angle C is 13.4 degrees. From that, I can add these two up and subtract from 180. So they add up to be 143.4. So angle B is probably 36.6 degrees. Again, you can use law of sines to check this. This over the sine of this. Is it equal to this over the sine of this? Is it equal to that over the sine of that? Okay, so let's do the next one. This is where it's imperative. So in this problem, and I want to try to get through this case before I close this video out. So side A is 18.3, side C is 27.1, and angle B is 8.7 degrees. So I hope you can see that there's nowhere that you know only two here, just two, or the A's and the C's, you only know two pieces of information. So you've got to turn to this format of the law of cosines. And in order to find side B, we're going to take the square root of all of that. So A is 18.3, C is 27.1, minus 2 times both of those, times the cosine of angle B. Now that's a guaranteed first step. Solve for the letter that's opposite the included angle. That's what this is. This is the included angle. So when you crunch that, you should get 9.43. Stop and pause the video, should you not, and try that again. So next, I have to solve for the smallest angle next. So between the 18 and the 27, I must solve for this one next. And I'm going to do it properly. So I would do that by taking 18.3 times the sine of angle A equals the 9.43 over the sine of the 8.7 degrees. I'll go ahead and type this. So I'm going to take this product. So the 18.3 times the sine of 8.7. And then I'm going to divide that by 9.43. What's opposite my unknown? But I'll remember that that's just a ratio for the sine of angle A. To get the size of angle A, I'll go second sine, second answer. And I see that angle A is 17.1 degrees. So this is 17.1 degrees. Look at how small this angle was. And see this right here? When you add those together, you get like 25.8 maybe. And so this needs to be 154 point, probably 2. I'm seeing, yeah, 154.2. Watch if we had done this problem incorrectly, and that's how I want to finish this. Watch if we had solved for angle C first. So if we had used the B's and the C's, so I'm just going to put here watch. This is wrong. So this is wrong, so be careful. If I had chosen to go for angle C before angle A, and if I had gone 27.1 over the sine of angle C and that equals side B over the sine of angle B, and then I got my calculator out to do that calculation. So 27.1 times the sine of 8.7 and then divide it by 9.43 would have given me a ratio for the sine of angle C. And if I went second sine, second answer to get that angle for angle C, I'd have gotten 25 point, it must have been 0.8 or something like that. Yeah, 25.8 degrees. Look, the actual answer for angle C was 154, not 25.8. So angle C turns out to be an obtuse angle, an angle that's much bigger than 90 degrees. And the reason for that is, remember, all the trig functions are positive here, but sine and cosecant are positive in the second quadrant. So when I got this ratio of 0.434694, that ratio was for a second quadrant angle. But I didn't know it. And how would I know it? I can't. I don't possibly know it. So I find the smallest one first, so the biggest angle shows up, because I wouldn't think to take 180 degrees minus 25.8 to get the 154.2 degrees, because I have no idea that this is a big, big obtuse angle. Short of, I will say that you could draw a picture of this. And so, side A was 18.3. Let's see. And I'm going to make side C be this one, 27.1. And then I'm going to do this. So here's how I made my picture. I'm letting this be B, which is 8.7 degrees. And therefore, this is side B. And then I'm going to, let's see, A is the 18.3, and C is the 27.1. So this would be angle A, and this would be angle C. So look at my picture. See that big angle in that picture? I got it by drawing a small angle B, side A being smaller than side C, and this was the included angle between those two sides, and I can see that big angle right there. I better pause to give you time to think about a case 3 problem using law of cosines. You see that we use law of cosines first, and then we quickly switch back to law of sines. I'm going to cross this off so that you remember that that's wrong.